Before we start the next problem, let's take a look at some symbols that are going to be different. So, when we are talking about our unknowns, we're talking about the entire group of interest. And so the population is that big group, maybe all US adults or all college students. And then the parameters, what we want to know about those populations, either a percentage or an average that has to do with the whole group. And so, whether we're talking about categorical data or quantitative data, we use P for a parameter if it's a proportion. And here's what's new and exciting. We use mu for a mean for the entire group. So mu is for the entire group. Now, we also often need to talk about the standard deviation for the entire population. And so, similarly, we use the Greek letter sigma for the standard deviation for the whole group. Now, generally, we don't know these, right? They are unknown values. What we do know is from our sample. So, our sample is that smaller group that we contact in a survey. The statistics are what we know for the sample. Now we're used to p hat. So p hat is the sample proportion. But as we move to talking about quantitative data, we're going to be using X bar for the sample mean, and we're going to be using S or SD for the sample standard deviation. So we have this chart here that should help. Now that we've gone over those symbols, let's take a look at a hypothesis testing problem. So here's the same sort of question, but with some slightly different data. In this case, we are again trying to figure out how much sleep adults are getting. But now instead of asking this yes or no question, do you get more than 7 hours of sleep per night? Yes or no? We're actually asking people how much sleep they got. So we've collected the data here, and we're going to ask some questions about this. Is there evidence that college students get less than 7 hours of sleep on average? So we've got this data. We're going to answer that question. And just like before, this is a four-step process. Okay. Now, the four steps are the exact same steps they were before. We're going to come up with some hypotheses. We're going to check some conditions. We are going to find a p-value. And we're going to state our conclusion. So just like before. Now let's start with our hypotheses. When we were talking about proportions, we used P because we were talking about the whole group. In quantitative data, we use mu because we're talking about the average for the whole group. So my null hypothesis is going to have an equal sign, just like my null hypothesis had before. So it's going to be mu equals. And then because I want to test if it's less than 7 hours, the number I'm interested in is it equal to 7? For the alternative hypothesis, I'm interested in that average being less than 7. And that's again coming from the question that I'm posing. So notice, like before, mu matches with mu, 7 matches with 7. My null hypothesis always has an equal sign, and my alternative hypothesis, the sign in the middle is going to depend on the question I asked. Now that we've got our null and alternative hypotheses, we can check our conditions. And we've got two conditions to check. The first is, do we have a random and independent sample? And we do. We're told that it's a random sample of students, so we meet that condition. The other condition is similar to what we saw for confidence intervals. We need one of the following to be true. We either need a large sample size, meaning that n is greater than or equal to 25, or we need our data to be unimodal and symmetric. Now, in this case, our sample size is 25, so we meet this condition. I don't have to check if it's unimodal or symmetric because I've already met the large sample size condition. Now we're going to find our p-value for this problem.